Rich, Michael, welcome to Talk Python Me. Great to have you two here.
Hey, thanks for having us.
Great to be here.
Yeah. It's a pretty interesting topic, these tables. You know, when I first heard about it, I was like, it sounds interesting, but how are we going to talk about tables on the podcast? And, how much is there really to talk about with tables? Turns out there's a lot, and we're going to find a way to talk about it on the podcast. So it's a pretty deep topic.
There's so much. You don't need 2 hours.
And honestly, like what you said just now is like story of my life for the past year of like being like, what could tables do? Like,
yeah.
And then just
df.head, doesn't that just solve it? Come on.
Right.
We already got that.
Like we already live. It's already so perfect. How could we improve on that? But yeah, I'm really excited because this is me kind of like fanning over Rich, but like I think it's like the perfect way to frame it. Like, what's up with tables? I feel like having pulled that thread for the last year, I'm always excited to talk about these things here because like I don't even being able to recapture how freaked out I am by whatever I just experienced for the past year with tables that Rich is chipping away at is really exciting.
Tables.
You know what? I would say probably my impression, which I will grant you is a pretty fresh take on this. It's a little bit like, oh, well, we already got Excel. You can draw graphs with Excel or Altair, Plotly, those types of, it's like, oh, wait, there's actually a lot more we could do. That's pretty awesome.
Yeah.
And the language too. I feel like having discovered there's a whole vocabulary for tables, I feel like was really enlightening.
Yeah, I would think so. There's almost like design patterns of tables. So we're going to get into that and like structure and some history and many things. But as per usual, before we jump into that, let's get a little bit of background on you guys. Maybe quick introduction on the two of you, how you got motivated to get into working with great tables and that sort of thing.
Yeah.
Rich, you want to?
Yeah. So I'm Rich. How to get into tables? I mean, I had to make tons of them. So that was sort of necessity. So the problem was it was annoying to do, like really annoying. Either doing it in Word was repetitive, not reproducible, which kind of annoyed me. I had to redo tables all the time because we had to use a tool that was outside of like programming, right? That was like a major problem, actually. You had to retranscribe them. There's many of them. It was kind of ugh. So
right, and with I opened with you could automate the graphs, but you couldn't automate the tables, right?
Exactly. Yes, it was like the one last thing. So that was like where I came from with tables, and years later, I finally got to it. I mean, better late than never.
Yeah.
Awesome. I came in mostly to support Rich, so a lot of what I've done is work as like a data scientist in R and Python, and I've always kind of had been kind of split brain, so doing a lot of data analysis in R and more engineering tasks in Python. But I think as I noticed Rich was kind of bringing this table idea to Python, I talked with him a bit and then I peeked through the code he was working on, and I was sort of really intrigued by how much was there. Like I would say the first thing that really kind of surprised me is just how much code he had was just more than I kind of thought tables would need. And so
this is more than one file. I mean, come on, don't we just put out a header and put out the rows? And
it was
there's a lot going on here for people who are not familiar with this.
Yeah, right.
I surprised myself too with how much I wrote. I mean, it just kept snowballing, the amount of things that had to be done.
Yeah, I'm sure.
And we both came from academics, so we both did PhDs, and I think we both produced like a decent number of tables as we did that. But yeah, never quite dove as deep into the more as intricate.
Yeah, and probably most of the time, you're knocking out something in Excel or LaTeX or something like that. And that's done. It's kind of done. It's not not live in the sense like every day I want a new tabular view of the status or whatever, like the dashboard sort of deal. What were your PhDs in?
I did chemistry, of all things.
Yeah. Chemistry. I love chemistry.
Yeah.
Yeah. Organic chemistry was one of my favorite courses I ever took in college.
I loved it too. Yeah, organic was great.
Yeah, beautiful.
Yeah, and I know
Michael?
I know very little about chemistry. I did cognitive psychology, so
okay,
tables in the mind or something. I don't know, something like that.
Yeah, absolutely. Oh, that's cool. So you must have had a lot of experience with trying to present your research and your thesis and stuff through tables, right?
Yeah, big time. I think I counted like something like 100 tables, including like the raw data section. So yeah, no shortage of tables there, and a lot of it came up in presentations and stuff. Had to remake them. Again, no good tool. So I was like, I felt sad, but I had no time to like pursue a tool. So I just kept going.
Yeah, I will say too, I kind of picked up too as I started working with Rich that he's a supreme dabbler. Like he has collected tables from across the world in a lot of different domains. So that's one thing that caught me too, was like, I don't doubt he produced a lot of chemistry tables, but I was amazed that I felt like he was like a guy in an alleyway trying to like sell me tables. Like, oh, you looking for like a sports table? He's like, oh, you like basketball? You like
the first bracket's free, and then
yeah. That's how he gets your hooks.
Yeah, it kind of is like that. Yeah, try to make tables possible for everybody.
Yeah. So how do we want to kick this off? I just want to say to all the listeners who are not watching the YouTube live stream, but are just listening, like most people who listen to the show do, we're going to do our best to describe some of these things. Some of them are visual, but I think we can pretty much capture the essence of them. I will try to set up chapters and put some chapter art. So keep an eye on your podcast player or your CarPlay view of Now Playing or whatever it is that's playing the thing. It might show some pictures. We'll see what we can do with that. But let's start off the conversation here, not on great tables exactly, but maybe just some examples of some good tables to give people a sense of just, what more could you possibly do than just, dataframe.head or something to that effect. You know what I mean? So I think it was Rich who sent this over. What do you guys said? A visualization gallery from Andrew Weatherman.
And it includes tables.
Yeah. It has got some awesome tables. And these, there are 10 tutorials here, and a lot of them are based on code, a lot of them from R and stuff like that. But which one do you think we should talk about, just as an introductory example, maybe?
Pretty good was the first one. The very first, like it leads with a table at the very top of the page. It's called
the conference realignment travel.
Yeah.
Okay.
And right away,
so if we open this table up, there's pictures so this talks about, like, what is this? A basketball college, American basketball.
Yeah.
So you've got the logo or the icon, like the Stanford tree or the Miami, Florida U, which is like the school colors. And you've got little chiclets of the information. Those are also embedded in sort of a heat map. There's a lot of pieces of this conveying information all at the same time. You want to maybe just riff on that a little bit?
Yeah, I don't mind trying to tackle this table. I'm just taking it in. I think it's really nice. So this table, basketball realignment travel in the ACC. So they're talking about, I guess, how hard would it be for these teams to drive to games? And so in the table, every row is a team, and they use like the logos next to the team name, so it's really fast to look up. And then in the columns are things about like visiting arena to home arena. So like how many miles would it take for this team to travel to the arenas they're going to. And I think that what's nice about this table is, for example, there are multiple measures of how many miles it would take a given team to go to their visiting arenas. So, for example, on the first row, we have California, and in columns, we have like median miles for one column and average miles for another column. But I think what's nice about just kind of basic table structure is because these two columns, median miles and average miles, are both kind of about a similar thing. They're able to put a label over it called a column spanner, and they label it visiting arena to home arena. So they're able to do a little bit of grouping of information. So you can see like these two measures, these two columns are related to each other. And then I like,
yeah, Michael, that's a super interesting point that I think is very well represented in grade tables. And that is almost multi-dimensional data.
Yeah.
Right. And so, like you say, it's got 3 columns here: median miles, average miles, and then this other geographic center column. But above those, there's like groupings, like these 2 columns speak to how far is the visiting an arena from home versus the other one is just sort of an extra description, right?
Yeah.
So you're able to say, here's this axes of information, but you can really group them together and think of them as something else that's representing almost, or something combined, like a projection. I don't know, something like this.
Yeah, totally. And I think the interesting thing too is like in databases or in data analysis, this kind of structure is there, but it's not visual oftentimes. Like someone might have a table and they might have 2 columns, one for like median miles, average miles, but they might actually like, oftentimes people in the name will put the grouping. So like if those 2 columns are related, they might say like visiting, prefix it with like visiting underscore. And so it's interesting, like tables, raw data tables often have these hierarchies, but this kind of lets you pull it out visually. So like the human eye can quickly kind of group things. And then to your point about multidimensional, that is kind of like one of the big benefits of a table is that this, for example, this table has 3 columns related to miles, and a plot, you could show that in a plot. You could plot 2 columns against each other with a scatter plot, and maybe use the 3rd column another way through like color or size. But you're at that point, you've kind of maxed out the plot. There's not a lot more you can do. A table, you can just keep adding columns, and they don't even have to be numeric or like kind of on the same scale. You could add like all kinds of information in columns and keep going. And I think to your point of it being multi-dimensional, that's one kind of nice thing table support is many measures on the columns.
Yeah, absolutely. Yeah. Out of the audience, Carol points out that the ACC used to be mostly Southern based, but now they span the whole US. But what you can see from this chart is this table rather, that all the Southeast based universities have a much easier time, right? The color of their little chiclets of distance are all very light colored. Whereas if you look at all the California West Coast, it's like distance across the US is your average distance you travel to each game, right? And it's pretty wild. You could probably put in things like what is the team's typical winning outcome based by distance, right? If it has to play a team that is twice as far away, is it more likely to show up? Are the players more likely to show up tired and not quite be able to play as good? And then that might somehow affect the rankings just based where you physically are located.
Yeah,
that's what makes this a good table, because like it basically tries to get that slice of the data, right? That one view of the data and present it so nicely. And then you can causes you to think those things, right? To explore further.
Yeah, exactly.
Yeah,
I don't know that I
again,
would have
ignites your
even thought that
imagination, really.
before.
Yeah.
Yeah, but looking at the colors, you're like, oh, California, as in Berkeley and Stanford, and those types of schools, they're much darker versus, Louisville, which is not very much, or Duke, or all these other teams. And then you start to realize, like, oh, maybe distance does play an important role. It just jumps right out, even though this is not a thing that I think about or care very much about on a lot of levels, but
Yeah. And even to Michael's point, that last column is like a total like qualitative measure, or not it's quantitative, but it's basically just like a label rather than like a number, essentially. So like it's much easier in a plot. I don't even know how you would do that. You just I guess, but here you can.
Yeah, just to describe the last column is you're talking about like furthest. So the last column shows what's the furthest team from. So each row is a team. The last column is essentially what's the furthest team from you, and they're able to just put a logo in to get a quick kind of snapshot, and you can tap on that extra column.
Basically, if you were to play an away game at that team, that's the worst travel for you. But at least measured by distance, if not like by time. And like if you're taking a flight, you could have 3 connections to a small town versus a direct one that's far away, right? Like there's different metrics you might apply to what defines furthest, but yeah, it's a neat idea.
Yeah, it's interesting though, right? Because they didn't bother to like rewrite the name of that team. They just economized the space and just like threw it in case you're interested. It's like
and the value for that column is not the name of the school; it's the school logo. Yeah.
And I will say, I can't believe that the year is 2024 and we just had a 5-minute discussion on the design of a single. I didn't imagine myself being here a year ago, but it's really
this is a solved problem, isn't it?
Telling about it to me.
Yeah, amazing. I feel like Edward Tufte must come into existence a lot for you guys. Like,
but it kind of goes to show tables can be cool, right? Like we're actually talking about this table, and it's interesting and it's good to look at. And like, I don't know, like this is like a leisure thing. I'm not compelled to look at this.
Yeah,
I'm looking at this for fun, and like it actually is okay. I enjoy looking at this table.
Yeah. I'll pull one more down. I have no idea what I'm gonna be getting here, but let's do Spotify listening. How long do I listen to my top artists before skipping?
Yeah, I think to your Tufte point too, this is a good example that you can have a little bar chart inside your table. So like this table, how long do I listen to my top artists before skipping? Each row is an artist with some information about them. And then the big thing, it sounds like, is this average stream duration column, which has a bar of how long people stream them on average, maybe before skipping. Right. Yeah, I love your point about Tufte, like this idea that you can encode a small like visual, like a bar, is very, I think, Tufte, like with spark lines and things like that. Tables can have a really compact representation that bring in some of the value of charts, but also it's like 3/4 table, 1/4 chart, and that's kind of a
for those out there who are not steeped in Edward Tufte sort of lore. He's a guy who thinks very deeply about data presentation, not necessarily tables or graphs or whatever, but just I have a bunch of kind of data stats based information, and how could I possibly present this in the way that conveys the most information easiest, so on. So yeah, he's got some great books, some great presentations out there. That's why I brought it up, because it's his whole career is about how do you present data, basically, right? Anything you guys should add to that? What do you think?
I think there is I don't have it on hand. There is a quote, I think, from Tufte. I don't want to butcher about, there is some analysis he's done of tables of like your entry architecture or something, which is essentially like the structure of the table, where you enter it as a user, and then like how you read. usually determines your like orientation. So like if you're reading left to right, there's usually like the table structure has like an entry point. And then if you're reading left to right, it kind of determines how you're going to go through. He's done some thinking about tables as sort of architectures, I think, but I haven't gone too deep into it.
Me neither, but I guess that informs like things like sorting that we saw in other tables. Like there's a dominant sort. The most important things are at the top, maybe least important, but there's definitely some sort of like, like conscious sorting, and like it's obvious what it is, and it's just sort of serve a purpose.
Yeah, there's probably an art to finding the thing that attracts your attention first, and so then as you progress through looking at it, you can do so in a deterministic, purposeful way rather than just you land anywhere and you start looking around visually.
Yeah. It's wild because like it is such a creative act making a table. It seems weird to say it. It's not just results you just slap down. You have to envision yourself in the viewer's shoes and like how they would ingest or like digest the information in the most easiest manner possible, with all sorts of like little affordances, like the way you format things, spacing between columns, all sorts of wild little tiny details. They all really combine to like make something really good, or to make the table shine, I guess you could say.
Yeah, absolutely. I want to come back to this one about the listening, and I'll link to all these in the show notes, of course. Here we've got the average stream duration, and it's represented by like little bars in the table itself, which we've already talked about, which is awesome. And the values are things like 87%, 80%, 84%, whatever. That little section is fraught with possible misrepresentation. So if that was just a number and it was average seconds, well, if you listen to, say, the Scorpions or some of the older rock bands or Iron Maiden, I don't know, where they have songs that are like 7 or 8 minutes long versus more modern songs that are maybe 2.5 minutes long. And it said, hey, look, I only listened to these like 2.5 minutes, but I listened to the Scorpions for 3 minutes. That must be the winner, right? Like, no, you're not even listening close to the same amount. So putting numbers even there, even before you would normalize them, right? Just put them as a percent of that as like the total average of the song or something. There's a lot to think about with these things, and that can kind of go away with these graphs, right? You don't have to worry about that. You're like, you don't have to worry about how long is their average song. You can see, just how long did I listen to their stuff. It's kind of cool.
Yeah, it's really cool. And it's a great use of space too, right? Like a horizontal bar plot. I mean, these are like rows which are not that high, but you still fit a plot in. We don't have that many choices, but horizontal bar plot.
They could be just
like
a couple
amazing.
pixels high, and you can still see that kind of information super well, as long as you use enough color or whatever. All right. Well, let's talk about great tables. So I feel like we probably have set the stage well enough for people to go, okay, maybe there's something here rather than just header, rows, and columns. So tell us about great tables. When did it come into existence? Why did you guys build it? What is it?
Yeah, Rich, you want to hit it?
Yeah, sure. So I actually started from an R program or package a long time ago, back in 2018. And like there's like essentially like a list of projects that were sort of like not being handled at then our studio, now Posit. And tables was there. It's like, oh, this seems like such an obvious one. I will take that. I will work on that. And I have an interest in that. I'm going to do it. Nobody else did it. It was on that list for years. And it kind of begs the question, like, why? Because tables are such omnipresent, way of presenting data. I see it like in, I don't know, like journal articles, like half the things are tables, half the things are plots. And they're, everywhere else. So like, yeah, there should be this thing. So I decided to just get going on that. And as Michael said, like it's a lot of code, and like I didn't envision it would take that much code. I thought it'd be rather simple, working with the HTML table, and then expanding towards other types of like table outputs, like PDF, Word and stuff like that. But I thought those would be bite-sized little things. As it turns out, tables run pretty deep. And I really only found that out when looking at, I was doing some like literature review, and I found that 1949 Census Manual. It's like the review of tabular presentation. Yeah, it's a great PDF that lives on the internet. It's always there. Thanks, whoever.
What year is this from? 1949, and it is.
Yeah.
It's like a janky,
Yeah.
scanned in thing
Yeah.
that they let you line, but it's
tables, you know.
This is like hundreds of pages of table stuff. It's both a style guide for the census at the time, and also just like an amazing like reference for anything tables, and even just presenting data. Like they go so deep on the smallest little things. It's incredible. Yeah, they sketch things out. They give things names. That was super important, because otherwise you'd just be saying that area on the top left, whatever that is.
Yeah,
it's good to have names.
It's almost like design patterns for that, right?
Yes.
Yeah.
And this is what was needed, and I'm very thankful I found this. Otherwise, we'd have to make it up. But this seems like as close to a standard as we'll ever find on this sort of thing, on making tables.
Right. So, from 1942, we have the formal table and its major parts continued. You know, amazing.
Yeah. They and there's so much good text. Like, it's expertly written. This stuff, I mean, of course, these are tables in print, and of course we have the web, so that changes things a little bit. But you'd be kind of surprised how still relevant these recommendations are. They teach you to be economical with how much data you put on. Basically the Tufty thing, how much ink are you going to like spend on a visualization? And it just carries it through to all the different parts, which is, amazing. And we took a lot of that and applied it here as best as we could, with some more modern things as well. But
yeah, of course.
But it's, very much a very useful reference, like the foundational reference for this.
So right on the Great Tables page, you've got the components of a table.
Yeah.
You want to give us a sense of what's beyond header, rows, and columns?
Yeah, Michael, would you?
Sure.
Yeah.
Yeah, I think so. I mean, I think even just the very first thing at the top, this table header with a title and a subtitle, that's like, that seems like a really simple thing, but I think that it's easy to overlook. Like a lot of people think of a table as just the like data and maybe some labels, but if you think about like the information hierarchy and someone who has maybe 10 seconds, 5 seconds to figure out what's going on, as it turns out, the title is probably one of the most important parts, because it tells them in 2 seconds, what should I expect from this thing? So like if you send to your boss a table, if you had to do one thing, you should probably put a title on it so that they know what you're sending to them. And I think, so that's like maybe a silly thing, maybe it feels like table stakes, but I think like the title and the subtitle are small elements that really kind of, if you're thinking of a table as communication, you wouldn't write an article without a title. So this really is just
critical. You probably wouldn't put a graph up without a title.
Yeah. Right. So it's kind of bringing tables up to the standard of other communications. Yeah. And then I think the other thing I really like is these are really simple elements, but these footnotes on the bottom and source notes, this idea that if you just create a spot for your like references, it's a lot easier to get into the habit of referencing where things came from. So like we have some table examples in our gallery, and in their footnotes, they often say where we got them from. And it's just so helpful having that like hook that you can hang into to quickly, like as a quick reminder that if you make it easy to put your references in footnotes, you just can make a habit of it. So those are kind of funny. Those are like the bookends of a table, but I really appreciate that they're there to emphasize how critical they are if tables are a form of communication.
Yeah. The one that stood out to me, and I called out at the first table we talked about, was the spanner label. That kind of says these 3 columns are kind of in some category together.
Yeah, the hierarchy is pretty important. It lets you sort of like, oh yeah, I care about this package or this set of columns, or maybe I don't. Maybe I care about these ones over here. You just quickly get oriented to like the columns that, are more useful. And also it allows you to do that thing that Michael mentioned before. You don't have to like have tons of like label on the below columns, like on one label, or tons of text on one label. You can split it up between like the spanner and then like the things it's associated to, the columns. So you might have things like some type of measure and then like the units for the column labels, for instance.
Yeah, in our basketball example, it could be distance from visiting arena. Then it could just have average, or miles from visiting arena, and then just average and median, and that's all it has to say. But you wouldn't have average and median as column label unless it was really, really clear. But in a complicated thing, it wouldn't make sense to just have those two words, like average of what,
Yeah, as part of that visualization, thoughtful design that allows you to be creative and also thoughtful for the user.
Yeah,
or the reader, I should say.
I think it helps too, because a lot of tables I've seen go big on columns. There's like quite a few. There can be tons of columns. And so I think when you have like, let's say you have a dozen columns, if you have like 2 or 3 spanners over them, it feels easier. It feels like closer to a table with 3 columns in a sense. When you get started, you kind of know what you're getting into, so you can kind of ease into it.
Yeah, you can kind of zoom in by picking a spanner and then paying attention to those pieces or something.
Yeah, totally.
As well, having these tools at your disposal as well also kind of like lets you be, like I said, creative, but also it gives you options to explore different ways of creating a table. If you didn't have like the ability to put a spanner, say in this program, this Python library, you'd have to think of other ways. You'd have to. It basically changes your whole presentation, not having options to do so.
Right. You'd want to try to leverage color maybe to try to infer that they're grouped somehow, but then, it's incomplete for sure.
Yeah.
So Iannone out in the audience asks, like, there's a lot. R has lots of great examples, but I've struggled since it's not equivalent in Python. Any suggestions or tips? I kind of feel like great tables is the entry point for a lot of that, right? What do you think?
Yeah, I think too, maybe something, Rich, you can hit on is there's a lot to appreciate from the history of R. Like, it's really surprising to people how hard people have gone on tables in R, and some of everything leading up to Rich working on GT in R, tables in R in 2018. There's actually like a 20-year history leading into that. That maybe, Rich, you can talk a bit about to kind of set the stage for what our users.
So
let me just add before you guys just jump in real quick.
Yeah.
You guys both we didn't catch this in the introduction bits. You're both working at Posit, the company that created Shiny. It was an absolute leader in R and now has Shiny for Python and all those kinds of things. So just adding some background history for everyone. Okay, go ahead.
Yeah, so basically R goes back probably about as far as Python, 90s or so. But R seemed to have a head start on tables. I mean, as far back as 2000, they had a LaTeX sort of table generating package. And then in the intervening years, the decades since up to now, they've had upwards of 8 to 10 table packages. I think it had to do with the fact that data frames are just like, is part of the language. So it just made sense to make a table. And also they just had, I guess, a lot of tooling for creating PDFs, especially for like package like references. So basically R has tons of like examples, vignettes and things like that. Maybe not so much on the Python side. We're trying to get that in, although I've been maximal on the table examples for the R version of this, which is called GT. Haven't quite got there yet on the Python side. So if you're seeing less examples than you might see on the R side, make sure that they are coming soon.
Still working on it.
Yeah.
So let's talk about the Python side, about what is my data journey to get something into great tables, and then maybe what comes out of great tables. So it starts with, sounds like Dataframe libraries. Yeah. Okay. What ones are supported? How's that work? What's the most ideal one?
Yeah. So we support out of the gate pandas and polars, and we've made this decision to lean pretty hard on polars in our examples, just because it has some kind of special moves that work really well with great tables. So for example,
selectors and stuff, right?
Yeah, selectors. So that really was eye-opening to us. And I think the Polars team a little bit. I think they hadn't, I think Great Tables was one of the first packages that went really hard in integrating with Polar selectors as part of our API. So there are, like, if you want to set a spanner label, so you want to set a label over some columns, you can use Polar selectors to do that in Great Tables. And that's a really nice, that's what we do all the time. And it's really convenient. I think that was kind of an early use of an external package for the Polars team using their selectors and stuff. So we had a lot of communication with them about it early on. But I would say, so it takes a pandas or a Polars data frame. And we've leaned pretty hard into Polars just because of some of these really nice affordances.
Yeah, if you go to the Get Started guide, you'll see it inside of selecting table parts and then like selecting columns, I believe. We have this little sidebar which sections up the getting started.
Oh boy.
Yeah.
Okay, getting started.
Oh, if you go to the very bottom on the sidebar, so scroll down.
Gotcha.
Yeah, that
Column selection.
column selection. So sorry.
There we go.
Yeah.
Yeah, no worries.
There's a whole using Polar selectors section. Yeah.
Oh, here we go. Here we go.
Yeah. So that's just an example of dropping Polar selectors into the Great Table method to move certain columns to the beginning of the table.
Yeah.
Or
you might do another example where you choose a number of columns to put a spanner over top of, and they might be named in a systematic way, which is like the advantage here.
Mm-hmm.
And you can do it for pandas as well, just not with selectors. You just use lambdas and such to have similar functionality.
Interesting. Okay.
Mm-hmm. Yeah. So yeah, pandas or Polars. Polars has some really nice benefits like selectors. And then it's used quite a bit whenever we style a table. We often use Polars expressions to kind of target the areas to style. So if you want to choose, like, for this column, make the maximum value of the column yellow, it's really easy with Polars expressions to say, when this column is equal to the max value in itself.
I see. Yeah, that's really cool. And because then you don't have to figure out what the max is and then try to come up with a gradient range of it. You just you put it into little bins or whatever. Yeah.
Yeah, exactly.
Yeah, totally.
One thing I just noticed that's pretty sweet about this actually is you already talked about the sources and the references and things like that.
Yeah.
But I just noticed that you have Markdown support for your references.
Yeah, that's a good one, because like sometimes you want to bold, italicize things, maybe make a list within your footer, your source notes.
Yeah, sure. I mean, even in the official way you're supposed to reference things, there's stuff that's supposed to be italicized and stuff that's not, right? And
exactly.
Markdown
so you basically want
pretty
these.
Well.
Yeah, so you want these tables to be useful for like a wide range of people, and if they didn't have that, I don't know what they would do. They'd just use HTML, I guess, and try their best with tags. But this is just an easy, obvious way to make it simple.
Yeah, that's really great. So we start with some data. We load it ideally into Polars, it sounds like, but Pandas is also supported. And then you kind of visually, I say visually, like the indentation of the way the code looks somewhat represents the structure of the table. A little Flutter or HTML-esque in that sense. Yeah.
Yeah, totally. I think we think a lot of it about in terms of three main activities: structure, format, and style. And we've tried to make the method names match up a bit. So everything starting with tab is basically about structuring the table. So that's those big pieces in the diagram we looked at, whether it's setting the title with tab title or tab header, or setting footnotes. Those are all structure activities. So they all start with tab. And then there's this just incredible bucket of formatters. Rich really went ham on formatting methods. So it's everything starting with FMT. This is like, this is like maybe you want to format the number of decimal places. But Rich has gone even further to like, maybe you want to put like a country flag in your table. Rich has got you. He wanted it to be easy to put country flags, and I'm here for it.
Yeah.
So
those little graphical elements are amazing for quickly conveying information, kind of like the logo of the various universities that you would see on Sports Center or whatever. You're like, yeah, that's what I'm used to looking at.
Yeah, that's right. You just use format image for that, and you just give it an image on disk or wherever, and
nice.
It gets in there.
Yeah, and I was kind of confused why I was adding so many formatters at first, but I feel like the thing that really clicked for me is that if you think about, so if you go up to the very top and then into the reference on the top bar, that will have lots of formatters under, formatted data.
Yeah.
They're just listed out. So what clicked for me is that spreadsheet users, so people in Excel making a table, are really used to tons of convenient things like formatting dates, formatting
right.
numbers.
You highlight a column, you press currency, then you press the move the decimal point 2 points to the left to drop the partial ones and all that. Yeah.
Yeah. So there's a world, like the engineer in me thought like, ooh, I kind of wish this wasn't our job to do all this formatting. But I think Rich very intuitively picked up on like, well, if people use Excel for tables, I think you have to give them a compelling reason to be able to do it all in Python, or they're not going to really want to make the jump. And so I think having all these formatters is just a way of bringing that kind of nuts aspect of Excel into great tables.
And some of the stuff is tough, like, and fiddly if you do it yourself. Like, I'm not just talking about simple like format, like strings.
Yeah.
I'm talking about.
Can I do like a colon and then a comma and then a 0.2 and we're done?
Yeah, first you gotta do that, and then like there might be some other weird things. So we try to like make it super simple with just some simple options, some arguments, and you're pretty much there.
Yeah, one thing I'll maybe give a shout out. I know you talked about it, PyCon, was if you've got a bunch of numbers, like let's say it's currency, you might want to format that using, like if it's over 1 million, 1.2 M, but if it's only 120,000, you might want to say 120K.
Yeah.
Right. Something where it's where it uses sort of an abbreviator.
Yeah, it's also useful if you have like tons and tons of numbers, like a wall of numbers. You're running out of space, so you just need to compactly. And like the small figures don't really mean much. Like you just want broad strokes. Like it just give me the compact thing. It's great, and it works really well for like things where you don't need to have that much precision. So you still need.
You also seem to have taken a pragmatic approach where it's not like, well, we're not going to let you mix units in a column, right? If it's not, kilometers and meters, like it's all kilometers, it's all meters, take it or leave it,
Yeah, I think
freedom, baby. That's what you want. you can target. So we have like a column targeting system, but you can also like sort of like subset like what rows you want. So that's the way. So basically you can like format different ways down the column if you so choose to, which makes it more flexible.
Yeah, I think it goes back to Excel, and Excel's just a big lump of clay. You can just carve out your table however you want, and it does like do formatting, but it doesn't prescribe. Yeah, like you said, it doesn't constrain you to have to like do it for a whole column. And I think that's like, we're endlessly surprised by the types of tables people create and the things they communicate. And in a way, it's like leaving room for surprise that people are so creative. You want some constraints, but you kind of also want to let them surprise you with things you wouldn't think of, but that end up being really useful. And I don't doubt someone's there like mixing all kinds of things in ways I wouldn't imagine, but end up kind of working out.
I think it was like in our table contests where I was like first surprised. Basically, we throw together table contests at Posit. It's such a nerdy thing, but like people submit tables and they get judged on them. Like they get prizes. Everyone's a winner.
Rich is a very kind judge, to be sure. It's like everybody wins. in Rich's house.
Yeah. But they're so good. Like when I see his tables, I'm like, I never even thought of that. Like that could be done. You'd want to do that. And I actually like it. Like, yeah, it's actually inspiring every time.
It's got to be pretty hard to build a framework around such a visual flexibility, you know?
Yeah.
But still have something prescriptive, right?
Yeah, I guess the trick is just like have easy conveniences just to do broad swaths of formatting and styling, but also make it granular and give people power, I guess you could say, along with simplicity.
Yeah. So tell people about these contests. If somebody wants to try their hand at great tables and submitting something, you know, I think we're even in the advent of code time, and I guess we just had the hour code stuff, but there's a lot of these things where people are trying. I just need some examples to play with to try to learn a thing, right?
Yeah, so we do it in the summer, so not wintertime, which is actually good for submissions.
Good, so it's still coming up. Yeah,
and we give a generous amount of time. I think like 2-3 months, if I remember correctly. But yeah, we just make the call, say submit your table. We have a nice form, and people submit them, and we sometimes get up to 50, sometimes 80 entries. It's like we get quite a few. And then we do the tough job of having a number of judges and just multiple judge grading of the tables. And we had so many that we had to split them up into categories, right? Because we were going to celebrate all these different types of tables and different domains of have typically different types of tables, and so it just makes sense to break it up in that way.
Yeah, and if I had to give advice, it's like much more freeform than a lot of the advent of code. Because there's no target or even necessarily starting point. It could be really hard for some people, I think, to get started or figure out like, what could I do with this? But I think if I had to give any advice, I think looking through the past entries is so helpful, like scanning past entries and even choosing some that inspire you. And then whether you take data similar to those and maybe try to do something related, or go in like a similar direction and look for new data. I think the existing entries are really, really inspiring. If I had to
get the creative juices flowing, right? Like, oh, I didn't even think you could go down that direction. Let's try that with my data.
Yeah, because I think if you start with just a blank page and you're kind of new even to great tables, it can be hard to know where to go. But once you start looking at entries, I think you get a feel for all the kinds of things you can do with it.
Oh, that sounds great. How important is it that you have interesting data to start with? Like, hey, let's grab the data that they use to image the first black hole and try to make a cool picture out of, table picture out of that.
Actually, that's a great question. I think it really hits on one of the neat things about these contests is that you don't have to have interesting data at all. Actually, one category of entry is kind of zany. It's like recreating something that exists in, say, like Great Tables or some other library. Like Rich and I were talking recently about GitHub issues. So like GitHub issues are a really interesting example of a table because they're a table that software developers work with nonstop. Like I'm all up in those tables all day. And it's like an interesting entry would just be to recreate that. Like if you recreated GitHub issues in a table and it looked really spot on, that's like its own kind of special accomplishment. And I think those entries are fun to see, like someone recreate an existing thing in Great Tables or something else. So yeah, to your point on data, I think you could start with even not having to find interesting data, but find an interesting table out in the wild and just try to recreate it.
Yeah. So I don't know if this has anything to do with your contest or not, but let me suggest an interesting angle to this in terms of like competitions for this, or just broadly for people who are listening. One is I've got really interesting data. I have a story to tell, and let me try to like really inspire you with my custom story. If you look at racing, like specifically auto racing, we've got F1 where everyone designs their own car. There are some rules, but they kind of they all have 1,000 or 500 people that work on it. Then you've got spec racing series like Indy, where everyone has the same car, the same engine, or there's 2 choices, whatever, same thing. And then they compete. So it would be interesting to have a category that is like, this is the data. You have to work with this, but tell a story. Like, who could tell the story the most interesting with like the same data, which sounds a little bit Kaggle-like, I suppose.
Yeah. Or Tidy. Have you seen Tidy Tuesday?
Tidy Tuesday?
Yeah, Tidy Tuesday. I think it's exactly what you're describing. Every Tuesday they release a data set.
Yeah.
And then people, oh wow, it's very, there's a GitHub repo somewhere where they.
Yeah, if you search for Tidy Tuesday GitHub, you'll definitely find it. But essentially, yeah, it's just like data, and you're left to your own devices about how to present it. It could be tables, plots, anything.
Yeah, I'm surprised the big Tidy Tuesdays. It's kind of a tricky one. I think there's a Tidy Tuesday organization, but yeah, same data, and yeah, people analyze it and then they share it out on socials.
Yeah.
So you get to, I think exactly to your point, like you start from the same place and you see where people get to. And I know like 1R user Dave Robinson for a long time would screencast himself live analyzing for an hour.
Oh,
so
wow. Okay.
Watch, like, what does it look like for someone to analyze the data? And I think that's a fun dimension too that you don't see often. Like, just how does it unfold? Like,
right.
At what point does he plot, and when does he go backwards? You know?
It's like the Bob Ross of tables. You know, like the happy little trees come first, and then this and that. Oh, that's how you make that picture. Okay.
Right. Yeah,
it does take time. Yeah. I mean, like just yesterday, I was making new examples. I'm always surprised how long it takes to make a compelling example for a table. It's like, it takes time. You have to mess with the data.
Yeah. And I will say this coffee table example that Marco pointed out. So the coffee table example for people listening is it's an example table we created where every row is a like coffee device. So it's the idea this table is for like a fictional coffee device shop. And every row is a coffee device. And then there are columns on like, oh, how many did we sell? How much profit did we make? And then there's a column that's little bar charts that show the monthly sales broken down. And
try hovering over one of those bars.
Yeah. And if you hover bars.
Yeah. So this is one of the things I wanted to make sure that we got a chance to talk about, because we've talked about having images in here, which is great. And the, what is this thing called that this group
Spanners.
Spanner. I can only think splitter. I'm like, no, it's not splitter. Yeah. It's groovy. The spanners and the colors and stuff there. But then you have what in the framework is referred to as nanoplots.
Yeah.
Right. So that we already saw the bar graph, but that was just an example. But here we've got like a little bar chart. And Rich, as you point out, as I interact with it, it's like a little plotly type thing. Like if I were real young and my eyes were real good, I could read the
exactly.
I could even read the labels.
Yeah. They're very small, but you have very little space. So like,
I mean, they're nano size. That's why they're called that.
They're not even microplots. They're just nanoplots.
Exactly. Few instruments. That's all we got here. Let's go.
They're meant for HTML and meant to be lightweight, slightly interactive, just to give you a little something, to mouse over and to drill down.
They're massively important because it shows you. It's. I had Stephanie Mullen on a little while ago, and she has this project that sort of, if you want the same information about the statistical summary of some set of data, like the standard distribution, the mean, the max, the min, and it could be like one little blob, or she has this thing that'll animate it into like a kangaroo or something, and it's got all the same information. You have the same problem with tables here, right? Like the total amount sold, the percent sold. But if you look at the nanoplots, some of them are really spotty and some of them are pretty much flat, and that it tells you a whole nother dimension. This is kind of what I was getting at. Like you could make this multi-dimensional, and that's another piece of communication that isn't just, rows and columns.
Yeah, it's nice condensation too, because each of those bars could very well be a column, right? You could have like a January column all the way up to
exactly.
Yeah, so it just shrinks it down. And it's useful.
So instead of having a
information.
table and a plot,
Yeah.
and you got to like jump back and forth, like it merges these two ideas in a pretty cool way.
Yeah, sort of explain the difference
Yeah.
between tables and plots.
I like too that with the nanoplots, like these little bar charts, maybe their job, like in a lot of tables, their job is to focus you onto a row. Like if you notice that pattern's interesting, it pulls you onto that record, that row, and then that lets you visit other columns to see like supplemental information that maybe suggests what could be happening, or like gives you information to look up more as you're doing an analysis. So it's kind of a neat like visual pattern as a way to index onto interesting cases. And then table columns have the power to give you more information about these cases.
Yeah, also, yeah, that's cool. It seems like because you can put Markdown into these pieces as well, you could have them maybe jump to the full size plot or something more rich as you want to like kind of expand a row or something.
Yeah, totally. I think there are interactive table libraries too. So one we have ported to Python recently is called Reactable. So we made a port called Reactable Py that it offers expanding tables. So if you're interested in a row, you can click it to expand down, say like more information or even a lot of like detail and description. But I think to your point, yeah, that's a really neat possibility of being able to like click and either be taken somewhere or have the table like open up. And
yeah, that would be cool to have an inline capability.
Yeah, I do want to know one thing about this table that I think about a lot is I'm so glad that Marco brought up it was useful because we spent a long time. We spent, I think, a couple weeks creating this table. And I talk about this with open source developers sometimes that I think about this, like how long we spent on this table, because this table's job was to illustrate like structuring, formatting, and styling in like what should be like your first encounter with great tables. And so we really, in a sense, as we created this table, we were on the hunt for a table that both introduced people to a range of activities, like looked nice, but also had code that we could explain. And it's like so hard. I feel like as open source maintainers, sometimes to find that like right example, like compelling, shows off like a range of activities, but also is approachable. And I do remember like Marco, one thing that opened my eyes is I think he shared this table on LinkedIn once, but he shortened it to like 3 or 4 rows. And that I'm always really interested in seeing those types of activities because I think that post really took off. And I don't know, it always like teaches me the power and the value of really like getting an example down and getting it so it's interesting, but also like short and compact is like such a art that some people are so good at.
Yeah, it's very cool. We don't have much time left, so I want to focus on the last bit of this journey that data goes through with great tables, and that is what happens. Where does it go at the end? You know, like what can I export? Yeah. So we talked about HTML and this interactive bit, but what are the different places that you could send this to?
Well, I think the big ones are Notebook. You're just iterating through some data and you want a table. Maybe you want to present that as well. So Notebook is like a really good example.
So maybe you put that actually just in a cell and just as part of the notebook, it just runs there. Yeah.
That's right. And the other one is just like you want it somewhere else. And maybe you want it in a presentation. You want a graphic. So we have a facility for that. It's the save method. We just let you get a image file or even a PDF from the table. And sometimes you just want to take that HTML and run with it somewhere else, maybe embed it somewhere, maybe put it inside of an email. So we have an as raw HTML method, which gives you an HTML string that you can just like pop in somewhere else.
Nice. And does that just give you like the worst possible HTML in the sense that like every thing that has a color has the style set straight on it and stuff like that?
You have 2 different stages. You can have it like with a style block, like sort of like as a one div with the table and the style block embedded. Or you can have all the styles inlined, which is a new feature, which is actually useful for emails.
Yeah, exactly. Because as much as you want to write nice stuff, we can't have nice things because a lot of the email clients forbid you from putting styles in there. Most notably Gmail. Like if you put a style, even a solid style block, it'll just throw it away. So you've got to just jam it onto everything. If that thing's gonna be bold, it's in a span and it has, style font weight bold on it,
When I first learned of that, like years ago, because I'm in the email game as well, I was like, really? How does this exist in this year? But it does. It still exists because of certain clients. So yeah. But luckily, there's lots of like great, and we have it here too. But there's lots of people have developed libraries to inline CSS into tags.
Yeah.
For this very purpose.
I guess one more output. Sorry,
Michael,
is a LaTeX, right?
Yeah,
as the final destination. Yeah,
that's a new thing. So if you're writing a paper, you want a table in it. We now have some way to get the table.
If you want your academic paper or your dissertation to have it, like, and it goes.
Yeah.
Sorry, Michael, what were you gonna say?
Oh no, I think one interesting thing too is I think .show, we have a really great contributor, Ju Young, that prompted this. I think because he was teaching a workshop to vision impaired like data scientists, and so .show is handy to be able to call .show and have it open a browser with the table. I think was like really useful, and that was so helpful to have as a issue in. I think that contribution to Great Tables is really huge.
Yeah, because then a screen reader could read it.
Exactly. Yeah, you have facility for that. But also, it's kind of disappointing to work in the console and not have anything being shown. It's like, what? So that's really good.
And it is. I see Carol noted Quarto, which is actually the whole Great Tables website is built with Quarto, and that's a nice format. So it uses a file called a QMD, which is a lot like Markdown, but it can run the code. And Quarto is really convenient for building things like websites or HTML reports. And it's also developed by Posit. But we end up putting tables a lot in like Quarto documents or the like Great Tables website through Quarto.
And maybe it's too bashful to mention it, but he developed like the library core doc, which makes this site possible and makes those tables rendered.
Oh, that's awesome.
Michael, that is.
Oh yeah, I guess for context, so like some tools like IBIS, their API docs and the Great Tables docs, we just created a small tool called QuartoDoc to let them put their like API references in these websites so they can use Quarto.
Yeah, that's excellent. Yeah, very, very cool. All right. Well, I think we're pretty much out of time. I guess give people a sense of where you're going, like roadmap type stuff. Is anything they should be looking out for?
Yeah, I think we want to port quite a bit more from the R program over to Great Tables. That includes things like merging, concatenating values from different columns into single columns. Things about adding footnotes to tables, so the footer is more put to better use, and more refinements to formatters and additional formatters. There's quite a few more things to go, but even right now it's pretty mature. But there's probably things people will ask for that I haven't thought of. So that's
I think
Iannone is asking for Excel.
We'll just put Excel in there,
Yeah, like
the snake will eat its own tail.
Excel's a big one.
And then we'll put Great Tables in Excel, so you can just go all the way to the bottom wherever that is. Well, I think one other thing to note is extensions. That in R, tons of people have extended GT, the Great Tables for R, and tons of like helper packages, like for like if putting a bar in your table is something you want to do, there are like a lot of these inside extra helper packages. And so I think one nice thing would be we want to kind of create a like example helper package just to give a feel for how people in Python could also create this kind of stuff for Great Tables. If you want to extend like, if you wanted to create your own little bar charts in Great Tables, like that. It seems like people have done a lot of that in R. And so it'd be cool to try to foster that kind of ecosystem and extension.
Absolutely.
Yeah, that's awesome. All right. Well, I'm going to leave everybody with one parting thought, and then I'll let you guys give a final call to action. Looking at some of these examples, especially those 10 ones that you called out, Rich, that I'll link in the show notes. If you're doing a presentation to your company on your blog as a data scientist, or just generally, it's so easy, I think, to just have the tables and then maybe somewhere you have a picture or something. But if you put something together like that, that will get people's attention straight away, right? It's just really another level of production. Yeah. And the fact that you do it with Python means it's reproducible. You do it once and off it goes. That's pretty excellent. So if that sounds like something you all do, you should check out Great Tables. It looks pretty excellent. All right.
Yo,
Michael, give a final call to action. People wanting to get started with Great Tables. What do you tell them?
You know what? Visit Great Tables, probably on GitHub. Check out the examples. I think the examples are such a helpful way to get started. And then if you get any questions at all, we have a Discord, or we love hearing from people in the issues. We want to hear from you.
Read it all. We consider it pretty carefully. Not carefully.
Awesome.
And then I think to your point, style pays. You just gotta churn out those beautiful tables. There's no other choice.
That's right. I think also once you set up one of them, if you kind of do similar types of tables, you can reuse that code in a lot of ways. So unlike doing it in a design or something. All right, Rich, final word.
Final word. Contribute. If you want to, it's more of a call to action. Just get into the site, discuss things with us. Even if your idea is way in left field, we'll probably consider it and maybe even do it. That's how eager we are to please when it comes to tables.
Awesome. So PRs are accepted.
PRs, anything, issues, complaints, whatever.
Beautiful. All right. Thanks for coming on the show, guys.
Yeah, thanks so much.
Yeah, congrats on the project. See you later.
See you.